What if the world's most dangerous substance could be turned into glass? China just did the unthinkable, and it might solve a 70-year nuclear nightmare. This isn't sci-fi, it's real, and it could change everything. A glass solution. How China may have solved the nuclear waste crisis. For over 70 years, nuclear energy has promised clean, powerful electricity. But it's also come with one haunting challenge. What do we do with the radioactive waste it leaves behind? Across continents, radioactive materials, fuel rods, sludges, and contaminated equipment sit buried, sealed, or submerged. But none of these solutions are truly permanent. They're temporary bandages on a problem that lasts millennia. And now, with the global push for low-carbon energy, this invisible crisis is growing. But something unprecedented is unfolding. While most countries struggle to even contain their nuclear leftovers, China may have found an elegant, almost unbelievable solution. A method that could finally offer long-term safety without relying on centuries of human oversight. It sounds like something out of science fiction, turning nuclear waste into glass. Yes, glass, the hidden burden of nuclear power. Nuclear energy is often praised for its efficiency and low carbon emissions. It produces no smog, no greenhouse gases during operation, and powers cities around the clock. But every watt of power comes at a cost. Highly radioactive waste that remains dangerous for tens of thousands, even hundreds of thousands of years. Globally, there are now over 250,000 metric tons of high-level nuclear waste. Every year, over 10,000 more tons are added. These aren't just statistics. They're toxic legacies stored in outdated facilities, near fault lines, water sources, or populated cities. When spent fuel is removed from reactors, it's too hot and dangerous to handle directly. So it's placed in water-filled pools that absorb heat and radiation. But these pools were never designed for decades of use. Yet in many places, they've become long-term storage by default. Once the material cools, it's placed into dry casks, giant concrete and steel barrels. These canisters work for now. But they have lifespans of around 40 years, require constant maintenance, and pose long-term risks if neglected or damaged. They don't eliminate the threat, just delay it. The final solution was always thought to be deep geological repositories, burying the waste deep in stable rock formations. But despite decades of talk, most countries have failed to implement them. The US Yucca Mountain project collapsed under public and political resistance. Others, like Germany and Japan, have faced fierce opposition. Only Finland has a near-complete repository in Onkalo. So the radioactive backlog continues to grow with no clear end in sight. Then came glass. Amid this global stalemate, China has quietly done something revolutionary. Rather than hiding the waste, China decided to transform it. Using a process called vitrification, Chinese scientists have started converting liquid radioactive waste into solid glass blocks. It's not a new concept. Western countries like France and the UK have tested it before, but they never deployed it on a meaningful scale. Too expensive, too complex, too inefficient. China, however, took a different approach. Backed by heavy investment from the China National Nuclear Corporation and national research institutes, vitrification was pushed out of laboratories and into functioning industrial plants. And the results could change everything. What is vitrification? In basic terms, vitrification involves mixing radioactive waste with glass-forming materials, usually based on borosilicate glass, the same durable glass used in labware and cookware. This mixture is heated to extreme temperatures, over 1,100 degrees Celsius, until it melts into a uniform liquid. As the molten mix cools, it hardens into a dense, stable glass block. But this is no ordinary glass. The radioactive particles become chemically bonded into the glass structure, trapped at the molecular level. They can't leak. They can't move. They're locked in place. The result is a stable, inert product that resists corrosion, water, temperature swings, and even radiation damage. Studies show these glass blocks can safely store nuclear waste for up to 100,000 years. That's longer than many civilizations have even existed. Why this matters, unlike steel barrels or deep caves, vitrification doesn't depend on outer containment or perfect environmental conditions. The waste becomes its own barrier, and it's compact. Glass blocks take up less space, don't require cooling, and are far easier to store and transport. They don't need complex surveillance systems or constant maintenance. They're simply still. China's vitrification facilities are designed to process large quantities of high-level waste. Entirely automated and robot-operated, they minimize human exposure while maximizing efficiency. And these aren't just prototypes, they're operational plants with real output. The implications are massive. With vitrification, nuclear waste can be handled at scale, not just in experiments. It could free the world from its dangerous reliance on outdated storage pools and fragile casks. For the first time, we may be able to render radioactive waste not just hidden, but harmless. A new era for nuclear? The most powerful change vitrification brings isn't just technical, it's psychological. For decades, nuclear power's future was shadowed by its past. Fear of meltdowns, fear of leaks, fear of toxic waste lasting longer than human history. These fears weren't unfounded, but they were also paralyzing. Vitrification reframes the issue. Instead of hiding from the danger, we're transforming it into a form we can manage. It doesn't eliminate the radioactivity, but it contains it in the safest, most stable form science has yet created. And perhaps even more important, it gives people hope. The image of liquid radioactive sludge sitting under neighborhoods or near rivers has kept communities from accepting nuclear solutions. But a block of inert glass, solid and silent, stored in a shielded vault? That changes public perception. It changes the conversation from, where can we hide this forever, to, how can we manage this responsibly, not without challenges. Of course, vitrification isn't perfect. It still requires safe facilities for storage. It still needs long-term oversight. The final disposal sites for the vitrified blocks must still be chosen and built with care. And not every country has the infrastructure or investment power to copy China overnight. But the key difference? We now know it can be done. At scale, safely, permanently. A turning point. Lu Yong, chief engineer at the China Atomic Energy Authority, called vitrification the most difficult part of safe nuclear use, and the most important. His words ring truer than ever. With the launch of China's vitrification plant in Sichuan province, the country became one of the only nations to master this full process on a national level. This isn't just a scientific milestone. It could be a turning point in how humanity handles one of its most dangerous legacies. It means future generations may not inherit unstable barrels of lethal waste. They may inherit carefully stored glass blocks, monuments to a time when we finally got it right. The big question. So now, we stand at a crossroads. The technology exists. The proof is real. The crisis is ongoing. The only question left is, do we have the will to act? To invest in this new future? To stop kicking the radioactive can down the road and start locking it away? For good? If we truly care about clean energy, about the planet, about future generations, the time to decide is now. Let us know your thoughts in the comments. Would you support this glass-based solution in your country? And if not this, then what? Thanks for watching Rookie Fact Finder. See you in the next one. Till then, keep exploring.